So the numerical is like that. Solve the simultaneous equations using Gauss-Seidel method. So we have here 4 equations. So here the equation 1, equation 2, equation 3, and equation 4. The first of all, what we have to do? So we have to check for whether it contains a greatest element along the diagonal or not. For first equation, see here, 4x1 means this is the largest element. So among x1, see here. And for x2, so here it is 4, and okay, there is no x2 in the third and fourth equations. Okay, so it satisfies the condition. Similarly, you check for x3. So here x3 is 1. In first equation there is no x3, it is 0. Now here x3 is 4 and x3 is 1, means this also satisfies the condition. And by default, fourth equation, it contains 4 along. Now all diagonal elements contains larger. So in this case, no need to perform partial pivoting. So I will write only simply short form partial. No need to perform partial pivoting because already it satisfies the condition. So all greatest element are lying along the diagonal. Once this is clear, so next step, what you have to do? So you have to convert these equations. So first equation in turn, write this first equation in terms of x1, second equation in terms of x2, third equation in terms of x3, and fourth equation in terms of x4. So same thing it is written here. So first equation you convert this into x1. So x1 is equal to, so 4x1 is equal to 150 plus x2 plus x4 plus x2 plus x4, because this is 4x1. So then x1 is equal to, so whatever amount we got divided by 4. So likewise, you have to convert this equation in this form. Similarly, second equation you convert, x2 is equal to 180 plus x1 plus x3, so divided by 4. Okay. So similarly, you convert this third equation, so into x3. X3 is equal to 100 minus plus x2 plus x4. Okay, divided by 4. Now third equation also you convert. So this x4 is equal to 180 plus x1 plus x3 by 4. So likewise, you have to write, first of all, you have to write so each equation in terms of variables. For first equation, you write in terms of x1, second equation in terms of x2, third equation in terms of x3, so fourth equation in terms of x4, and so on. So if it contains 4, so you use only 4. Okay, once you have written this, the next step, so we have to find the solution. Write a given equation in terms of variables in sequence. So that we have did here. So variables in sequence. And then, so this is the steps belongs to this. We have written in sequence. First equation x1, second equation in terms of x2, third equation in terms of x3, and fourth is, equation in terms of x4. And then, so we have to start with iterations. This is the first iteration. In first iteration, in case of Gauss-Seidel method, assume all variables. So this contains 4 variables. So one is x1, x2, x3, and x4. There are 4 variables. So you assign first. So first variable, second variable, third variable, and fourth variable values are equal to 0. So this is the first step. So next, what you have to do? So once you have assumed this, now we have to start iterations. For performing iterations, now I have not written here equations once again. See here, x1 is equal to, so this is, so I will write here. So this is x2 and this is x4. Now here, for first iteration, x1 is equal to 150, same equation. So this is the equation for x1. So 150, what x2 value we have assumed? X2 is equal to 0 and x4 is equal to 0. We have substituted x2 is equal to 0 and x4 is equal to 0 by 4. So we, on simplification, you will get 37.5. So this is first step. In the first step, so whatever value we have assumed, so those values we have to take. The next, we have to compute x2 value. For computing x2, so you can see what is the equation of x2 here. X2 is equal to 180 plus x1 plus x3. So this is value of x1 and this is value of x3. Now see, so in this case, you have to remember always we have to use the value, recent value of variable. What is the recent value of variable x1? So previous value of x1 is 0. Now recent value of x1 is 37.5. Now we have to use this recent value. Do not use this value. Use this recent value. And then what is the recent value of x3? The recent value of x3 is equal to 0. So I have substituted here, and on simplification you will get this. Similarly, so for third computation, x3 is equal to, so this is the equation for x3. x3 is equal to 100 plus x2 x4. So 100 x2 x4. Now in previous case, see here, for x4 we have used 0, but in this case, x2 we have used 0, x4 0, but in this case, so this is x2 and x4. Now see, so x2 in previous equation we have used 0, but here we have used 54.3. So it means that always we have to use this recent values. And then, so what is the recent value of x4? So we have not yet computed, but we have assumed in the initial step x4 is equal to 0. So it is 0. And simplify, so you will get x3 value. Now similarly, you go to fourth equation, x4 is equal to, now the value of variables is x1 and x3. See. So this is x1, x1, x3. Now here we have to substitute recent values. So what is the value of x1? Recent value of x1 is this, and recent value of x3 is this. So we have substituted the recent values and computed. So I think so you might have understood what is the logic involved in computing of first iteration. So you remember one thing. So always we have to use recent values of a variable for further computations. The same statement here I have written. So you read this, now you relate this sentence. So method solves each equation in a system for a particular variable, and then use that value, means whatever variable value we have computed in the previous, that value in later equations to obtain the solution of next variables. So this is the statement. So that supports this process. So now in the first iteration, so we got the value of x1, x2 is not, this is t1, t2. So this is x1, x2, x3, and x4. So x1, x2, x3. So these are the new values. Now if you want to perform iteration 2, so you should not use these values. For performing iteration 2, so use the values which are obtained in first iteration. So I will compute one more iteration. So I will demonstrate this with the help of some example. Okay, this is the second iteration. Okay, no issue. So we have a second iteration. So in case of a second iteration, so I have written the values which we have obtained from the first iteration. You can see here, this is the first iteration. X1 value is 37.5, X2 value is 54.375, X3 value is 38.59, x4 value is 64. So here it is not this t x. This is x1, x2, x3, x4. Now, so this is the basic equation we have to use. So the basic equation for x1, x2, x3, and x4. So after rewriting the given equation in this form, so that we have to utilize. Now we have to compute x1 value. For computing x1 value, so 150. So this is x2, x4. So what is the value of x2? See here, value of x2. I have indicated by same color, red color. So this is x2 value, and then x4 value. So this is the x4 value from previous iteration or iteration 1. So whatever value it is represented here from iteration 1. So you have to take these values and compute x1. Similarly, you go for x2. For computation of x2, 180, second 180, x1, x3. So this is x1 and x3. So we have a x3 value. So here, so the black color you can see here, this is x3 value. So we have taken x3 value from there, and x1, x2 value. So as we discussed, always use the recent value. So this recent value, x1 value is used, and so after computation you will get 71.432. Next, for computation of x3, so here it is x3 is x2, x4. So this is x2 and x4. See, in the recent, recently we have computed x2. So you take this value x2 for this, and x4. So from the previous iteration value, say previous iteration value, either this or this. Same we have written here, 64.023. So similarly for computation of x4, so this equation is x1, x3. So this is x1 and x3. So this x3 value already we have computed recently, and xn value is also computed recently. So you take these recent values and substitute in the equation, so you will get the values. So likewise, this is the logic involved. Just simply you can look at the arrows, so you will get so how to proceed with the problems. And also you can refer the color combination. See, pink color represents the recent values, and yellow color, so I used green color, it is from previous iteration, and so this color, blue color, also represents the recent value. So like this, based on the color combination also you will get the idea, and also I have represented with arrows. So this is the logic involved in the Gauss-Seidel method. It's a very simple method, but here you have to perform n number of iterations. Now we have to write these in terms of table. So this is for second iteration. Whatever values I got in the second iteration, I have written. First value 67, second value 71 point something, and third 58.861, and fourth 76.1. Similarly, you have to perform n number of iterations until. So this is the values I have computed, but I have not presented because it will take a very long time. So because it involves very simple logic, so you can apply and you do these calculations for third iteration, fourth iteration, fifth iteration, sixth, seventh, eighth, and ninth. So okay. So you note down this equation, otherwise you take the screenshot of this. So from this you will get everything. So you can compute further iterations. After 9 iterations, you can see up to, so if you are considering x1 variable, so up to 1 decimal place, so 2 decimal places, 0.91, 0.91. So you will get 2 decimal places, accuracy up to 2 decimal places. So here also you can see almost all in all variables you got results, or we got results up to 2 decimal places. See here. So only thing is that there is a difference in this CX2, but the majority of this got the accuracy up to 2 decimal places. So if it is mentioned accuracy up to 2 decimal places, so then you have to perform one more iteration. So because this is not satisfies the condition, x2 variable does not satisfy the condition, so therefore you go for one more iteration and then you can stop. So definitely you will get accuracy up to 2 decimal places in 10th iteration. So likewise, so the when to stop, where to stop, how to stop, so that will be decided based on the accuracy required. If it is a 2 decimal accuracy is mentioned, so then percentage of error, in that case, that computation I have not done here. So it is expected to do in the next forthcoming iterations or forthcoming numericals. So I will tell you how to perform percentage error calculation. So that I hope you might have understood this.